The previous video got us introduced to the exceptional phenomenon of scattering. We also conducted an experiment to understand the same. Okay, now, let's halt at the questions that we left you with in the previous video. We need to know, why is the sky blue during the day? And why is it that the sunrise and the sunset are usually red in color? Let's discover the answers to these questions in this video. We had mentioned that this happens due to scattering of light. But how? To understand this, we need to understand an important concept first. Among all the colors of the white light, the blue color tends to scatter the most in the atmosphere, while the red color scatters the least. And why is that so? Why does the blue scatter the most and red the least? That's because the blue light has a shorter wavelength compared to that of the red light. Hang on, what is wavelength? It's basically a property of light. But we will not get into the details of wavelength now, as we will learn about it in our higher grades. For now, let's just know that the different colors of the light get scattered differently due to their different wavelengths. Now, getting back to our discussion. Let's begin with the first case, that is, why is the sky blue during the day? Suppose you're standing at a point on the earth as shown in the image. At midday, the light coming from the sun is scattered by the atmosphere in all the directions. Any guesses what helps in the scattering of this blue color? It's due to the innumerable particles of gases present in the atmosphere, like the nitrogen, oxygen, carbon dioxide, and so on. But due to its short wavelength, the blue light gets scattered the most in the atmosphere, making it appear blue. So, this is how the scattering of blue light makes the sky appear blue during midday. Now tell me, if blue color scatters the most, then why does the sky appear red during sunrise and sunset? Let's understand. In this case, the position of the sun will be this with respect to the observer. Now, in the first case, during midday, the sun is perpendicular to the surface of the earth where the observer is. And in the second case, the rays coming from the sun are not perpendicular to the earth's surface. They enter the atmosphere at an inclined path. Geometrically, this perpendicular distance will always be less than this inclined distance. That means these perpendicular sun rays make their way through a short path of the atmosphere to reach us. Whereas in this case, the light has to travel a much longer path through the atmosphere. Also, the distance traveled by the light in this case is more as compared to that in the first case. Thus, in the second case, the blue light gets scattered multiple times by the numerous particles in the atmosphere. Also, the remaining blue light gets scattered more due to the long distance it has to travel. So, it gets almost vanished, and the only color that survives till the end is the red color. That is because it scatters the least because of its longer wavelength. This is why the sky shows a red or orange cast during sunrise or sunset. Beautiful, isn't it? So far, we know that the scattering occurs due to the atmosphere on the earth. Can you tell me what would happen if there was no atmosphere on earth? There would be no scattering, and all we would see is only the white sun, and everything else would just look dark. In simple words, we would see nothing except the white glowing sun, even during the day. Scary, isn't it? No wonder we are truly blessed to have the blanket of an atmosphere around the earth. With this, we come to an end with the concept of scattering of light. To learn some more interesting concepts related to light, do subscribe to our channel. Enjoy the learning.